Hey, it's me, Steve. It is July 13th, 2017 still. Temperature is 83 degrees Fahrenheit out still, but the time is 20:01. So I'm going to do another Geo-Rant because I was thinking about something when I was grocery shopping. I'm going to talk about weathering. Okay, on Earth we have three basic types of weathering: physical, chemical, and biological. There are some people that argue there's a fourth that involves things like solar radiation, but that could kind of fall under chemical, and like catastrophic, like asteroid impact, shock, stuff like that. But for the sake of argument, we're going to stick with the main three. Now, I'm just going to explain them quickly. I'm going to deal with the one that I don't really deal with in the rocks I study, because the rocks I study don't really have a lot of biology in them, but we'll talk about biological weathering. This is anything that's done, and actually you can kind of, the thing with biological weathering is you can kind of put it into physical and chemical as well. Basically biological weathering just means some sort of organism has altered the rock or sediment and begun to break it down and weather it. Typical thing, perfect example of this is something simply like a tree growing out of a couple fractures in bedrock. The tree will start to grow, it'll start to break down that bedrock and make it smaller and smaller until it becomes soil. But now I'm going to talk about physical weathering, because this is the one most people think of. Physical weathering is when you break down a rock through non-biological processes. Basically, rain, wind, water. This is when you just make smaller rocks out of larger rocks. So basically anything that's silt size and bigger in grain size has pretty much been physically weathered. Then we have chemical weathering. Now, chemical weathering is interesting because water plays a part in that, and actually wind does to a degree too, or I should say the atmosphere, because if you have an old banded iron formation that's exposed to the atmosphere, it'll begin to oxidize or rust, and that'll break the rock down. But the most common form of chemical weathering on the planet is the dissolution of limestones, of carbonates. Like when it rains, water will pool on limestone, get in between the cracks and fissures and pores, and slowly over time the water will react with those carbonate rocks and mineralizing the water as it flows through and breaking down the carbonate rock, and ultimately either dumping the mineralized water into the ocean or releasing it into the atmosphere. Which brings me up to something interesting. When you talk about like the planet Venus versus Earth, both have about the same amount of carbon on them. The main difference between the two planets is that all of our carbon is pretty much locked up in our rocks, limestones, coals, stuff like that. It's not free in our atmosphere. Now, we as living creatures also contain carbon, but the biomass is nowhere near as large as the rock mass that contains the carbon. As where Venus's carbon is pretty much all in its atmosphere. There's no carbonate rocks on Venus. There's no water cycle to take the carbon out of the atmosphere, and there's no living organisms to use that carbon. But anyway, that was just a quick rant. Hope you learned something.